Well, good evening. I think we got cut off for with part A, but that's fine. We're going to finish this up with part B of transformations of functions. It's from section 1.3. You have a handout. We're on the back side. We're at the top side where it says transformation of function graphs and reteach. Had a chance to do a little bit of looking at what we've done so far, and it looked like you could actually read the screen pretty good, so I'm glad for that. But we're going to try to finish this thing up. We're on this back side of that first worksheet there about transformation of functions on the reteach, and let's see if this is going to work okay. And I think we were right here, so we're looking at this guy right here. This is an absolute value function. By the way, on absolute values, where you find the absolute value bars on your calculator is let me pull this guy up here. So to find that, we're going to hit alpha y equal, not there, huh? So let's go over to window and see, there it is right off the top, the absolute values right there, and that's where you could find that. So alpha window is where you can find absolute value, or you can hit second 0 and that goes to your catalog. So let me hit clear here. Second 0, which is your catalog, and absolute value ABS is again the very first choice, and you would do that underneath the y equals to be able to get that, to graph it that way. But you don't really need that. It's pretty easy to do without it. It's real simple. The straightforward absolute value is just simply 1, 1, up 1 over 1, up 1 over 1, left and right. Okay, so it's basically this line, but then we took up half of it and made it positive. So that's what your absolute value graph looks like. And so when we see this right here, we got an x plus 3. So it looks like it would, so inside has to be left and right. So no, it's always backwards of what it seems. So it's going to be left 3 units. So every single dot here has been shifted 3 units. Okay, 3 units. And then over here, so we got the absolute value in the dotted lines. Okay, and then it's going up 3 units. Everything went up 3 units. There. So that's how, so inside, outside. Both of them have a plus 3, but you see how this was shifted 3 to the left, and this one was shifted 3 up. I believe we were walking through these examples right here when I got cut off previously. And so we notice here, this again is our parent function for a parabola, and there's some important pieces here. See if I might be able to pull it up doing it like this. Yeah, that's where we were. So we had taken this guy here and said this means left 1. So we moved every single thing left 1. And then for this one, since it's on the outside, it's down 2. So everything got moved down 2. So that's what you end up with, is this guy right here. And that is your transformed function. Okay. Now on yours, the doesn't match my. See, on mine it says these guys right here. So what I'm going to do is I'm going to come up here and I'm going to change out these guys, and so we're going to call this number 3, and instead of doing x plus 1, we're going to do x plus 5 here. We're going to do plus 5, and instead of x minus 2, we're going to do x minus 5. Put a 5 here. So what does this mean? Is instead of going to the right, so it's inside, the 5 is on the inside, so that's left, right. So kind of looks like right, but it's always kind of the opposite there. So that means this is again going to be left 5. So we talked about these points here being the most obvious points that we need to follow through with. So each one of those have got to move 5 points to the left. So 1, 2, 3, 4, 5. So all the way over here. And then this guy would have to move 5 over, and then 5 more over, and then over here, and then right there. And so your new transform graph looks something, ooh, in that neighborhood right there. Okay, and then this one, everything's got to go down 5. So again, we got these main points 0, 0, 1, 1, and then over 1 and up 3. Everything here. So we're going to go down 5 because it's on the outside. Okay. So 1, 2, 3, 4, 5. Right there. So okay, so there's your down 5, and that would have been number 4 of our examples. Now let's switch over to the other worksheet that looks like this. So if we just got finished doing this, it says x plus 5 inside with that's up squared, and it says left 5. What's it going to mean to us when we look at this? So this x plus 4 means what? Left 4. Left 4. Okay. And so everything here is going to be shifted left 4 units. Okay. So 1, 2, 3, 4. Let's go red. Right there. And then over 1 up 1, over 1 up 3, over 1 up 5. It's pretty rough. And this just simply says left 4. That's what that should look like. So this one is very similar to this guy here. So this is x squared minus 2. It says down 2. Well, this one says x squared plus 2. So shouldn't that mean everything shifts up 2? Ooh, what about that negative out front? What's that going to do to us? That's going to flip everything over, isn't it? So it's going to be the same exact deal. So, but is there going to be any shifting? No, it's just going to be a flip. It's a vertical flip for that matter, because it's on the outside. It's a vertical flip. So that flip that and nothing happens, but you flip this, you get right here. Get right here. And then you come down right here. Then you do another one on either side of that, and you finish that off. So if this right here is left 4, what is this down here? X minus 4 on the inside. That's going to be right 4. So everything's going to shift over 4 units. Well, what's this going to happen here? That's on the outside, that's up 2. This is on the outside -2, so I think we should be able to figure out what's going on here. Okay. Well, if we take this and move everything 2 units like it's supposed to be done, and then flip it, that would be kind of what's going on over here, because this is a flip and a move down kind of situation. Okay. Still holding the same shape. Oh goodness, what are we going to do about this? Well, what's this thing right here tell us? This is what, down 2, and this is going to be left 1. So let me get you started on this one. So we're going to have left 1 and right, whoops, not right, that's not, it's not, this is on the outside, it can't be left and right, it has to be up and down. Exactly, it has to be up and down. So this is going to be down 2, down 2. So let's go from here, we're going to go left 1, down 2. Then from here we can go left 1, down 2. So there's that guy there. Left 1, down 2. Left 1, down 2. Left 1, down 2. And so what you do is something along those lines right there. You would continue on putting more points in there for sure, I would say. So that's the idea there. And so you got 2 pieces here. You got a flip and a shift on that one. So you got a right left shift and a over, and a flip over. Okay, then we come on to the back here. We're going to start stretching and compressing a little bit. This is going to be getting a little fancy at this point. And so we have the absolute value bar graph right here, your original graph. Okay, this is your original graph. This is your parent function. Okay. And then we have the child function. And what is that? That's 2. Well, what is 2? It's 2 over 1 basically, right? So we're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So that is what's going on here. So same thing here, up 2 left 1, up 2 left 1, up 2 left 1, up 2 left 1, up 2 left 1. And then you would do like that, something like that. And no shifting left and right, you just simply start your vertex and do the rise and run. Parabola is going to be a little different than that, but it's pretty straightforward when it comes to an absolute value. Okay? So then this guy, 1 over 2. So what are we going to do? Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. So there's your 1/2. Then you fill those in, and you get your g of x. Now, again, the blue is the parent function. G of x is got what? You're going to shift it right 2 and up 3. So right 2 and up 3, and flip it over while you're at it because there's a negative in front. So vertex, and go right 2, up 3. Okay. And so you need to actually fill in. I got the dots started up here for you to get you going. Oh my goodness, what's wrong with number 14? It says write 4. Well, what would that look like if you were to write the function? Would it look like something like up here kind of thing? So let me ask you this question. If it says write 4, does that make inside or outside? Well, inside, because left and right's always on the inside. Okay, that's good. So is it going to be absolute value of x minus 4? Or x plus 4, because it's right? No, because since left and right is inside, but it's backwards, and then you would need to graph that down here. Okay, so you go right 4. Then you need to write this one. F of x equals absolute value x. So do we put this 2 on the inside or on the outside? Okay, so letting you get a chance to sink that in. So that's going to be up 2, so there's a plus 2 here. Okay, oh, lost track there for a second. And so that's on the outside. Let me clean that up. It doesn't look very nice, does it? Okay, then left 2, so that means it's going to be on the inside, like number 14 here. Okay, so it's getting a little bit fancier. Now we're back over here. You're going to probably, on 18 and 19, probably going to need a calculator for this guy to finish it off, 18 and 19. Well, good luck. Let me know. I'm sure I'll have some people in touch along the way. We'll see you on Thursday. Just do as much as you can. And whatever questions you have or that you haven't been able to get a hold of me on Wednesday through Remind, just have them organized and ready to go. So you're not having to figure out what they are. You already know what they're going to be.